May 1st, 1960, Sverdlovsk, Soviet Union. A Lockheed U-2 spy plane, flying at an altitude its CIA operators believed to be unreachable, is suddenly rocked by a violent explosion. A salvo of newly developed Soviet SA-2 surface-to-air missiles detonates nearby, shredding the delicate aircraft and sending its pilot, Francis Gary Powers, spiraling toward the Earth. This single event was more than the loss of a plane. It was the catastrophic failure of a strategic doctrine. The U.S. government, believing Powers to be dead, initiated a cover story, claiming a weather flight had drifted off course. This lie was publicly demolished just days later when Soviet Premier Nikita Khrushchev presented to the world the captured U-2 wreckage and, more critically, the pilot, Francis Gary Powers, alive. The international humiliation was profound. The incident shattered the spirit of Camp David and led directly to the cancellation of the forthcoming Paris summit. But for the CIA, the true disaster was the human element. Powers, captured alive, became a tool for enemy intelligence and a centerpiece for a global show trial. His very existence was a strategic liability. The mandate emerging from this 1960 humiliation was absolute. Flying high was no longer a sufficient defense, and the risk of a captured pilot was unacceptable. The CIA turned to its secretive engineering masters at Lockheed's Skunk Works with an impossible requirement. They needed a new reconnaissance platform with the speed and altitude of the A-12 Oxcart, the Mach 3 successor to the U-2, but with the political deniability of an unmanned system. They needed a suicide drone, a machine that could fly its mission and then vanish, leaving no pilot to be captured. This is the story of that machine, Project Tagboard. It is the story of the apex engineering that created the D-21, a flying titanium ramjet, and the M-21, its Mach 3 mothership. It is a story of pushing aerodynamics, material science, and propulsion to their absolute limits, a technological gamble that led to one of the most spectacular, tragic, and instructive catastrophes in the history of the Skunk Works. The U-2 failure created an immediate, glaring intelligence gap. The Soviet SA-2 missile had effectively closed the skies over the USSR. But as one threat was contained, another, equally pressing target was emerging: the People's Republic of China and its nascent nuclear program at the Lop Nur test base. This vast, remote complex in the Xinjiang desert was by the mid-1960s considered one of the most heavily defended airspaces in the world. China conducted its first successful nuclear test in October 1964, instantly elevating Lop Nur to one of the most critical intelligence targets on Earth. Yet it was a denied area in every sense of the word. U.S. spy satellites like the KH-7 Gambit were operational, but this technology was in its infancy. Satellites flew on predictable orbits, and their film-based capsules had to be physically retrieved from space, meaning the intelligence could be weeks old. The CIA needed the timeliness and flexibility that only an overhead aircraft could provide. But manned flight was deemed unacceptably risky. The PRC, with significant Soviet assistance, had established a formidable integrated air defense network. This included not only Soviet-supplied SA-2s, but also their own reverse-engineered version, the Red Flag SA-2. By 1968, PRC radar systems had become so advanced they could actively track U-2s from the moment they took off from their bases in Taiwan. The CIA's new weapon, the A-12 Oxcart, was a Mach 3 80,000-foot marvel. It was the fastest, highest-flying jet aircraft ever built, a titanium ghost designed by Clarence Kelly Johnson at the Skunk Works. But even this invulnerable successor was deemed too precious to risk. The political trauma of the Powers incident was still too fresh. The CIA was unwilling to risk losing an A-12, its revolutionary technology, and, most of all, its pilot, over the deep interior of mainland China. In the shadow of the U-2 disaster, and as the A-12 began to prowl the skies, the CIA dreamed of a spy that needed no pilot. This created the impossible requirement: a platform with the extreme performance of the A-12, but with the expendability of an unmanned system. The solution, authorized in October 1962, was Project Tagboard. The concept was a mother-daughter system, a marriage of two apex engineering programs. The mothership, designated M21, would be a specially modified two-seat version of the A-12 Oxcart. The daughter, designated D-21, would be a new unmanned reconnaissance drone. The mothership would carry the D-21 on its back, accelerate to its operational launch speed, and release it into the sky over a safe point. The D-21 was the literal mechanical answer to the ghost of Francis Gary Powers. It was designed to be non-recoverable. It would fly its 3,000 nautical mile mission over the target, fly back to a point over the ocean, eject its precious intelligence payload, and then vanish. The payload, a capsule containing the camera and film, would be snatched in mid-air by a specially equipped JC-130 Hercules, a spy that would vanish into vapor rather than be captured. It was the perfect, sterile technological solution to a messy human and political problem.
The Tagboard program represented a convergence of 1960s apex engineering, pushing the known boundaries of aerodynamics, materials science, and propulsion. It required the creation of two highly experimental, titanium-based aircraft, each a marvel in its own right, and then physically mating them into a single, complex, and deeply unstable weapon system. The launch platform, the mothership, was a heavily modified variant of the CIA's A-12 Oxcart. This aircraft was already a legend of the Skunk Works, pioneering the use of titanium alloys to withstand the 600-degree-plus skin temperatures of sustained Mach 3 flight, and incorporating the earliest forms of radar-absorbing stealth technology. Engineers selected 2 of the 15 A-12 airframes ever built, serial numbers 606940 and 606941 for the M21 conversion. The conversion involved 2 primary and highly complex modifications. First, the Launch Control Officer Station. The M21 was transformed from a single-seat aircraft to a 2-seat aircraft. The second cockpit, for the LCO, was installed directly behind the pilot, in a space formerly occupied by the A-12's main reconnaissance and equipment bay. This cramped, windowless rear cockpit housed the engineer whose sole terrifying purpose was to monitor the D-21 systems, prepare it for launch, and then initiate the separation sequence while flying at 3 times the speed of sound. Second, the dorsal pylon. A large, load-bearing pylon was permanently mounted on the M21's dorsal centerline, nestled between the 2 enormous all-moving vertical stabilizers. This pylon was the attachment point for the D-21 drone, which it carried in a slight nose-up attitude, piggyback style. This MD-21 combination was an aerodynamic and structural compromise from day one. The addition of the 11,000-pound D-21 drone, perched high above the M21's center of gravity, created immense structural loads and a host of complex, unpredictable aerodynamic interactions. The aircraft's flight envelope was severely restricted. All flight manuals for the mated configuration strictly limited maneuvering to a maximum of 2.0 g and prohibited most rolling maneuvers. This was to prevent adverse side loads from ripping the drone clean off the pylon during flight. The mothership, once the most advanced aircraft in the world, was now a compromised, delicate transport, a Titan forced to fly with extreme care. The D-21 drone itself was, for all intents and purposes, a flying engine built for a single high-speed dash. It was an unmanned 43-foot-long vehicle with a 19-foot wingspan, constructed almost entirely from exotic materials to survive the mission profile. The airframe was a monocoque, or single-shell structure fabricated from titanium alloy Beta 120. This, combined with composite plastics in its leading edges, was the only way to survive the skin-searing friction heat of sustained Mach 3.3 flight, which would melt conventional aluminum in seconds. The D-21 was powered by a single Marquardt RJ-43 MA-20S4 Ramjet. A ramjet is a deceptively simple form of air-breathing jet engine. It has no major moving parts, no spinning compressor fans, no turbines. Instead, it relies on the vehicle's extreme forward velocity to literally ram air into the inlet at supersonic speeds. This high-speed ramming effect compresses the air, which is then mixed with JP-7 fuel and ignited. A ramjet that screamed to life at Mach 3, unleashing thousands of pounds of thrust. This engine choice was the program's central, defining constraint. A ramjet, by its very nature, cannot produce thrust at a standstill or at low speeds. It is an aerodynamic brick. It must first be accelerated to a very high ignition speed by an external force before it can even be started. The D-21's Marquardt ramjet required it to be moving at over Mach 3 before it could ignite and become self-sustaining. This single fact of physics dictated the entire mother-daughter concept. The need for an unmanned suicide platform, the D-21, the D-21's engine choice, the ramjet, created a physics requirement, a Mach 3+ launch. This in turn created the engineering requirement for the only aircraft in the world that could achieve it, the M21. Project Tagboard was a fragile interconnected chain where each component was pushed to its absolute untested limit. The operational flight plan for the D-21 was a complex, pre-programmed sequence that showcased both the genius and the profound limitations of 1960s analog technology. First, the launch. The M21 mothership, with the D-21 mounted on its back, would take off and climb to 72,000 feet. It would then accelerate to its launch window, precisely Mach 3.12. In the rear cockpit, the LCO would start the D-21's ramjet, which would ignite in the supersonic airflow passing through its inlet. The LCO would then top off the D-21's fuel tanks from the M21's own supply and initiate separation, firing pneumatic charges to push the drone up and away. Second, the ingress. Once free, the D-21 would accelerate on its own power to its cruise speed of Mach 3.35, over 2,500 miles per hour. It would climb to its operational altitude of 80,000 to 95,000 feet and fly its pre-programmed 3,000 nautical mile route over the target, such as Lop Nur. All navigation was handled by an internal analog inertial navigation system. Third, the hatch ejection. The D-21 was a flying camera, but in an era without digital data links, its intelligence was a physical object, a spool of analog film. After completing its photo run and flying to a safe recovery point over the ocean, the drone would shut down its engine and enter an unpowered descent. At 60,000 feet, explosive bolts would fire, ejecting the drone's entire reconnaissance package. This hatch was a module containing the high-resolution camera, the exposed film, and the navigation system. Fourth, the recovery and destruction. The ejected hatch would deploy a parachute, a specially modified JC-130 Hercules aircraft, part of a fleet that had perfected mid-air retrieval by snatching film capsules from Corona spy satellites, would then fly in and snag the parachute in mid-air, winching the priceless intelligence package aboard. Having completed its one and only mission, the empty D-21 airframe would continue its descent. It was designed to self-destruct with an explosive charge if its recovery failed, preventing its advanced titanium and engine technology from being recovered by the enemy.
The ambitious, multi-stage engineering of Project Tagboard was now ready for its ultimate test, a live launch at full speed and altitude. The program, operating from the clandestine base at Groom Lake, Nevada, proceeded through a series of test flights that grew progressively more complex and dangerous. After 3 successful, though nerve-wracking launches, the program's invisible, inherent flaw was about to reveal itself in the most violent way possible. The 4th D-21 launch test involved the M-21 mothership, serial number 60-6941, and drone D-21, serial number 504. The test was to take place at Mach 3.25 over the Pacific Ocean near the Point Mugu test range. The crew consisted of 2 of Lockheed's finest, legendary test pilot Bill Park at the controls, and 33-year-old Ray Torick, a highly experienced flight test engineer in the rear LCO cockpit. This 4th flight, however, had one critical fatal difference from the previous 3. The first 3 successful launches had all been conducted with the M-21 in a 0.9 G dive, or a slight downward trajectory. This maneuver, likely intended to be gentle, used gravity and a slightly negative angle of attack to help pull the drone down and away from the M-21, ensuring a clean, quick separation. But this was not an operationally realistic maneuver. A dive over hostile territory like Lop Nur could alert enemy radar. The 4th test was therefore designed to be the first true operational simulation, a level flight 1G configuration. The M-21, piloted by Park, reached the launch parameters, 72,000 feet, Mach 3.25. In the back, Ray Torick initiated the launch sequence. The D-21's Ramjet ignited, the pneumatic charges fired, the drone separated. For the first 2 to 3 seconds, everything appeared normal. But the D-21, without the assistance of the 0.9 G dive, did not have enough force to clear the mothership. At Mach 3.25, the M-21 was encased in a powerful, invisible bow shockwave, a wall of compressed air. The D-21, separating with only minimal upward force, failed to exit the shockwave coming off the mothership. It bounced off this wall of supersonic air. This catastrophic aerodynamic interaction is believed to have caused an asymmetric unstart in the drone's Ramjet inlet, instantly starving one side of the engine of air. The 11,000-pound titanium drone became uncontrollable. It stalled, yawed violently, rolled sharply to the left, and cartwheeled through the air, striking the M-21. The drone, traveling at over 2,000 miles per hour, impacted the mothership near Station 715, the critical structural joint where the forward fuselage and wing root meet. The M-21, its titanium airframe fatally compromised, broke apart in midair. The M-21 was destroyed,
its wreckage tumbling toward the Pacific. The pilot, Bill Park, and the LCO Ray Torick stayed with the disintegrating forward fuselage for a short time as it fell, attempting to reach a safer, slower altitude before ejecting. Both men successfully ejected from the wreckage and landed in the Pacific Ocean. Bill Park, a veteran Lockheed test pilot, survived his injuries. He was located and rescued by a helicopter. Ray Torick was not so fortunate. Torick ejected, alive, but his damaged suit filled with water before rescuers could reach him. For Clarence Kelly Johnson, the iron-willed head of the Skunk Works, the loss of Ray Torick was a personal and professional tragedy. The crash was not a random component failure. It was a fundamental, inherent flaw in the entire tagboard concept. The 0.9G dive on the first 3 tests had not been a launch procedure. It had been an unwitting, lucky workaround for this fatal flaw. The moment they attempted an operationally realistic 1G launch, the flaw proved lethal. This implied that the M21-D21 combination was, and always had been, operationally unviable. The fluid dynamics of 2 separate airframes separating at Mach 3.25 were simply too complex, too unpredictable, and too lethally dangerous to guarantee the safety of a crew. Johnson's reaction was an admission that he had created an engineering problem that even he could not solve. Devastated by the death of his engineer, Kelly Johnson immediately and personally canceled the entire M21 tagboard program. The sole surviving M21, serial number 60-6940, was immediately retired and placed in permanent storage. It would never fly again. Johnson reportedly called the M21-D21 launch concept, in his own words, the most dangerous thing we had ever done.
The catastrophic 1966 crash killed Ray Torick, destroyed one of the only 2 M21 airframes, and ended Project Tagboard. Kelly Johnson, devastated, had declared the concept the most dangerous thing we had ever done. For any sane engineering program, this would be the end. But the requirement, the CIA and Air Force's desperate need to get reconnaissance imagery of the Lop Nur nuclear test site, had not vanished. The D-21 drone, though its launch system was a failure, was still a marvel of hypersonic engineering. The program was not allowed to die. It was resurrected as a zombie project. The D-21 drone concept was salvaged, and the CIA passed the problem to the U.S. Air Force, which codenamed the new effort Project Senior Bowl. Kelly Johnson himself, despite his aversion, suggested the new launch platform. It was a pivot from the most elegant, high-tech, and futuristic aircraft in the world to one of its slowest, oldest, and most reliable, the B-52H Stratofortress bomber. This pivot created an entirely new, massive engineering challenge. The M21 had solved the D-21's primary problem by accelerating it to Mach 3.3 before its ramjet ignited. The B-52H, by contrast, is a subsonic bomber that cruises around Mach 0.8. The D-21's ramjet still needed to be moving at over 2,000 miles per hour just to start. The Skunk Works solution was a testament to raw, brute force engineering. If they couldn't carry the drone to Mach 3, they would shoot it there. First, the D-21B modification. The drone itself was modified. Its ventral hardpoints, used to attach to the M21's pylon, were repurposed. New heavy-duty hooks were added to its spine, allowing it to be carried under the B-52's wing, much like the X-15 rocket plane. Second, the brute force booster. Engineers designed a massive disposable Thiokol solid rocket booster. This rocket was an engineering marvel in its own right and a logistical giant. The SRB was 44.25 feet long and weighed 13,290 pounds. In a supreme irony of engineering, the booster was longer and significantly heavier than the 11,000 pounds D-21B drone it was propelling. The launch sequence was now a display of raw, explosive power. Two B-52Hs were heavily modified to carry the 24,000 pounds D-21B SRB assembly under each wing. The B-52H would fly to the launch point at high subsonic speed. The crew would drop the entire 24,000-pound package from the wing pylon. This package would fall for several seconds, ensuring it was a safe distance from the B-52. The solid rocket booster would then ignite, firing with immense force for 87 seconds. This rocket, burning a solid fuel propellant, would accelerate the drone through the sound barrier and push it all the way to Mach 3.3, at which point the D-21's Mark R Ramjet would ignite in the supersonic airflow. Explosive bolts would fire, jettisoning the spent booster, and the D-21B would continue on its 3,000-mile mission alone. The M21 Tagboard had been an elegant, complex, and delicate scalpel. The B-52 Senior Bowl was a brute force sledgehammer. But the launch problem, at least, was solved. The program was now ready for its real-world test.
Project Senior Bowl, now under the 4200 Support Squadron, became operational in 1969. The launch problem, which had proved fatal to the M21, was solved. But in solving that one flaw, the program was now free to fly and to fail. The true incurable flaws of the D-21, its primitive analog navigation system, and its hopelessly complex recovery system, were about to be exposed in a perfect chronicle of failure. 4 operational missions were flown under Project Senior Bowl, all between November 9, 1969 and March 1971. All 4 targeted the Lop Nur nuclear test site. All 4 were catastrophic failures. 4 launches, 4 failures, a billion-dollar ghost swallowed by the sky. Mission 1, November 9, 1969. Drone D-21B, serial number 517. The launch from the B-52 was perfect. The SRB ignited, the Ramjet took over, and the drone began its run. The mission failed, however, because the drone's analog inertial navigation system failed. A later simulation by Honeywell, the system's manufacturer, determined the failure was likely due to a minute sine-cosine computation error in the analog guidance computer. It was a simple math error, permanently etched into its hardware. Instead of making its program turn to the recovery point over the ocean, the D-21B continued flying straight. It ran out of fuel and crashed, not in China, but deep inside the Soviet Union in Siberia. The program's very first operational flight had delivered its most advanced technology directly to the enemy. Mission 2, December 16, 1970. Drone D-21B, serial number 523. This time, the navigation system worked. The drone successfully flew its entire 3,000-mile mission over Lop Nur, returned to the recovery point, and correctly ejected its precious hatch containing the film. The mission failed, however, when the hatch's parachute failed to deploy correctly. The 300-pound package plummeted into the Pacific Ocean and was lost forever. Mission 3, March 4, 1971. This was the most agonizing failure of all. The drone, serial number 526, flew a fine flight. It returned to the recovery point, the hatch ejected, the parachute deployed. A JC-130 Hercules recovery aircraft moved in for the mid-air retrieval. The pilot missed the snag. The hatch, which was designed to float, landed safely in the ocean. A U.S. Navy destroyer was vectored in for a simple surface recovery. In a moment of almost unbelievable misfortune, the destroyer ran over the floating hatch, damaging its flotation bladder and causing it to sink just before the crew could retrieve it. Mission 4, March 20th, 1971, the final operational flight. The drone, serial number 527, launched successfully and proceeded on its mission. It was simply lost. It never returned to the recovery point, and its signal vanished. Wreckage from this drone was eventually recovered by Chinese authorities and later put on public display in a Beijing aviation museum. In July 1971, with a perfect 0% success rate, after 4 catastrophic and expensive failures, Project Senior Bowl was canceled. The program was dead. The M21 Tagboard had failed because its launch system was too dangerous. The B-52 Senior Bowl had failed because its recovery system, an analog Rube Goldberg contraption of parachutes, mid-air snags, and floating hatches, was too complex, too unreliable, and had too many single points of failure.
The D-21 program's only successful mission, in a deeply ironic sense, was its very first failure. The drone from Mission 1, which had vanished in 1969, had, as we now know, crashed in the frozen tundra of Siberia. Its wreckage was quickly recovered by the KGB. Years later, in the mid-1980s, a KGB agent, in a cynical diplomatic gesture, presented a piece of the wreckage, a fragment of the titanium alloy skin, to a CIA contact. This fragment was eventually delivered to Ben Rich, Kelly Johnson's successor at the Skunk Works, a tangible, physical symbol of the program's ultimate failure. The only ones to truly benefit from America's ghost drone were its enemies. But the main wreckage was not a trophy, it was a technical intelligence prize for the Soviets. Masters of reverse engineering, as they had proven with the American B-29 bomber, which they copied bolt for bolt to create their own Tu-4. The Soviets tasked the Tupolev Design Bureau to studying and copying the D-21. The resulting Soviet design, which existed on paper and in models, was named the Voron, or Raven. And here, the D-21 story finds its perfect final irony. The Tupolev Voron was never built. After studying the D-21's advanced, exotic, and flawed technology, the Soviet engineers came to the exact same conclusion as their American counterparts. The entire concept of a high-speed, expendable, film-based reconnaissance drone was a complex, unreliable, and exorbitantly costly dead end. They determined, as the U.S. already had, that reconnaissance satellites, which were rapidly improving, were a far more effective, reliable, and survivable solution for peering into denied areas like Lop Nur. The D-21 program, born from the political humiliation of the U-2 incident to prevent secrets from falling into enemy hands, ended with its only operational success being the free delivery of its most advanced technology directly to the heart of the Soviet Union. And that technology was so profoundly flawed that it served only as a multi-million-dollar lesson for both superpowers in what not to build. It was a failed program that inspired another, stillborn, failed program. It was a technological dead end for all, a suicide drone in every sense of the word.